Sorry. All right. Well, welcome to USC Man Class of 2028, Man 2028 Calculations. I don't know. We'll think of a better name. PHRD 514 Calc and Comp Supplemental. These videos are just for you guys to, have to really visualize and be able to read the questions and figure these questions out by yourself instead of, just jumping into whatever concepts you have memorized. This because down the line, what matters is how you grasp the simple concepts to apply to the more difficult concepts that we learn as we go through these modules and then throughout our labs that we'll be having later on as well. So we're going to start from the beginning because that we're going to make sure that everyone grasps that knowledge up from the beginning as well. It doesn't matter where you are. We're going to make sure that you have that understood before moving on to what may seem like the more necessary concepts to grasp for this class. So we're going to start with chapter 1. So moving on to our computer here. Okay, chapter 1. Hopefully you guys can read that on the board. How many of, let's see, 6.5 times 10 to the negative 1, 2, 3, 4, 5. 6.5 times 10 to the negative 5 gram doses can be made from 0.130 gram of a drug. So how are we going to grasp this? How are we going to, pull out our information? We have a total amount of 0.130 grams of a drug, and we want to find out how many doses can we make from that amount, each dose being this amount right here. So we're trying to see how many doses we can divide from this amount. See where I'm getting at? So it's pretty simple if just that's all right. So 0.130 divided by, let's just say 6.5 times 10 to the negative 5. You guys can double check right there for me. We're going to use our trusty calculator here. It's pretty similar to the one that we're supposed to be using. Divided by 6.5. Let's see, where is times 10 to the negative 5? That equals 2,000. So the answer for that is 2,000. For this question, sig figs aren't really specified how much they're looking for. So I wouldn't really worry about it. Maybe for the exam itself, usually they will specify, but for the cause of this class and such, we're just going to go with this amount, 2,000. All right. Moving on. Let's get a better one. Not going to go over all these questions with you too. We're just going to go over what maybe the ones with the concepts that you'll really need to maintain for our upcoming modules and labs coming up. But foundations, right? It's the name of this module, and it should be how your foundation for how you'll be understanding and interpreting these questions that will come up later on, modules B, C, and D. We're going to go over question 3. That was a homework problem. Just read it with you right here. The pharmacist had 5 grams of codeine sulfate. He used it in preparing the following. So there's different forms, different doses, and then different amount of capsules per dose. So there's 8 capsules, each containing 0.0325 grams of the drug, 12 capsules, each containing 0.015 grams, and then 18 capsules, each containing 0.008 grams. And the question is, how many grams of codeine sulfate were left after he had prepared the capsules? So we have a total amount of codeine sulfate. It was divided among these certain dosages for each a different number of capsules per dose. We just want to find out how much was left over from that original amount. So first we want to find out the total amount of each dose that was used, right? So there was 8 capsules, each one being 0.0325 grams. We want to know how much of the drug total was used for that amount of capsules per dose. So and then that goes for the 12 capsules and the 18 capsules as well. So 8 capsules times 325, 12 times 0.015, and 18 times 0.08. That's 0.008. Okay. So the cool thing about these calculators and also the calculator in your exam soft is that instead of just individually multiplying and adding these terms up together, you could just all put it together in one thing, one formula, right? So there's 8 times 0.0325. Whoops. 8 times 0.0325 plus, so I hope you see what I'm doing right here. We're separating them into parentheses so that not only are they multiplying each individual dose and total dose, we're also adding them together at the same time. Plus 18 times 0.008. All right. So that gives us a total answer of 584 grams. And that's another thing we should also double check before going ahead with our question. Probably should have done that with you beforehand too. Starting amount is in grams. What we're trying to interpret and calculate is also in grams, so we'll end up with grams unless they ask otherwise. If these were in milligrams, obviously we'd have to either convert the starting amount into milligrams or whatever we're calculating into grams. Either way, we just want to be consistent with our units, right? So total amount used for all these capsules with varying doses is 0.584 grams. That's not what they're asking for. What they're asking for is how much was left over from the starting dose. 5 grams of codeine sulfate minus the amount that we had. And just take a look at the calculator here real quick. I'm going to do something here. So this applies to a lot of later calculations where you have a lot of more complicated numbers and you want to make sure that you're using all of those numbers for your final answer before you round off. Because if you're rounding off in the middle of that and then you get an answer, it might not be exactly the same answer that you are expected to get. And that is really important for solutions, IVs. You want to make sure you're being as accurate as possible for these calculations. So this is a smaller number, that's fine, we could type that out, but conceptually, you should be using this answer feature right here. So second, and that negative, for this calculator, it's the negative sign. Second, negative sign. In green, it shows answer. That's basically just getting the answer from the previous calculation that you had for whatever next calculation that you want to proceed with. And so we're going to go ahead with that, and we get 4.416. Double check that, and that's correct. 4.416 grams of codeine sulfate. You get the idea, right? Cool. anyone wants to sponsor Man 2028 with markers and a actual nice eraser, I'd be more than happy to take that. All right, next question, number 4. If it's too easy for you guys, skip forward to our next videos, but I want to make sure everyone is covered, whatever it may be, right? Whatever your situation may be. Number 4, write each of the following in exponential form. So there's 2 questions for that. First one, a 12,650. All right. First of all, again, no specification of sig figs, so we're just going to go ahead with whatever numbers that we have right now. And just quickly to go over what exponential form is, it's just a simpler way of writing out numbers for just, to make things look nicer and clarify things. It also can help with calculations later on. So especially that applies to bigger numbers and smaller numbers. And we're going to be using base 10s. So we'll have a number and we'll either multiplying it by 10 times to whatever or dividing it by 10 times to whatever. Okay? So 12,650. We'll use all the numbers in that case, right? But it's a pretty big number, and we don't want to be, for scientific purposes, you don't want to always be saying 12,650. So the nicest way to go about it is just to have like one whole number and then the rest in possibly like a decimal form times however many tens it takes to get back to that original number. So for 12,650, for example, we can write it out as 1.265 times 10. So we're putting a decimal place at 1. Putting a decimal point at 1. We want to know how many tens it takes to get back to the full number, 12,650. So what we can do to count that is just to count how many decimal places it takes to get back to that original number, right? So there's 1, 2, 3, 4. Pretty simple. So you counted 4 or tens. And so that's your exponential form notation. 1.265 times 10 to the 4. Simple, right? So that applies to large numbers, but we can also apply to decimal forms and very small numbers. So B, for example, I'm not even going to count how many zeros. Well, I'm not going to say how many zeros there are before I explain this to you. But I see a 5.5. So we can write that, again, that goes back to that idea of writing it neater for when we're writing a paper out or whatnot. So 5.5. And that same method applies to this too. You put a decimal point right there, and then you count how many tens it takes to go back to the original number. 1, 2, 3, 4, 5, 6, 7, 8, 9 times 10 to the negative 9. Sudeepa, why is it negative 9? Okay, so to get from our notation to a bigger number, we're multiplying by 10. To get from our notation to a smaller number, we're dividing by 10, going backwards. And dividing by 10 is also, another way you could write dividing by 10 is also using negative exponents. So just for example, 10 to the negative 1 is also 1/10. So 1 over, what is that? 1 over 10 times 9 is also 10 to the negative 9. So that's where that concept is. All right. And that applies to units too. You can see milligrams per milliliter can also be written as milligrams times milliliters to the negative 1. If you've seen that, that's why. All right. It's pretty straightforward. Hope we're up to speed so far. Number 5. Find the product. Okay, we'll start with A. Um, Another rule about base 10s, that's what I'm going to call these, base 10s, because you're using that 10 and then manipulating whatever based off that 10. 10 to the 4th, 10 to the negative 2. And there's specific rules for that. So when you're multiplying or dividing, let's start with multiplication, right? If you're multiplying something with base 10s in them, instead of just, you can put in your calculator and get that answer. That's fine as well. But with base 10s, there's also a rule where if you're multiplying, so let's just start with this. This is all multiplying something into something. You could separate the 3.5 and the 5 from the tens as well. So we'll take those out and then we'll put the tens together because it's all multiplication, right? Associative, something like that. I don't know what it's called. Associative rule. 10 times 3 times 10 times 4, 10 to the fourth, sorry, 10 to the third times 10 to the fourth can also be written as 10 to the 3 plus 4. That equals 10 to the 7th. Now, you might be asking, how does that work, right? Think of like 10 times 10. 10 to the 1 times 10 to the 1 is also 10 to the 1 plus 1 is 10 to the 2, which is also 100. It's the same idea. So and it's not like a concept that you need to understand. It's just for the sake of making things faster for you. If you're calculating things by hand and you might not have a calculator on you, that's just another way of seeing it. So 10 to the 3 times 10 to the 4th equals 10 to the 7th. We can do 3.5 times 5 separately. And I think that's what, 17.5? Let's check that out. 3.5 times 5, 17.5. How about that, right? So we did these numbers by themselves and then the base 10s by themselves. You can still combine them together. So that's 17.5 times 10 to the 7. That's okay as it is. But remember what I told you about exponential notation? The preferred way is to have just one whole number in the front and the decimals beyond that. So this is okay again, but we can also write it as 1.75 times 10 to the, okay, how do I think about this, right? If we're going back one decimal this way, that means it's going to take one more extra 10 to get back to this number, the 17.5. So if we're moving it back one, we're going to have to add one here. So that's going to be 1.75 times 10 to the 8. Yes, yes. All right. Where's my eraser? Here we go. Okay, we can do B's, yeah. And I hope you guys are following this with your own document as well. To be, you know, you're more than welcome to just pause and try it out yourself before watching me do it as well. And a lot of the stuff I'm also just, trying to figure out myself before actually uh, explaining it to you guys, because that's how it should be. That's how it's going to be during the exam. You really need the time to assess yourself and see like what are we looking at before we start writing things down. Okay. 7.2 times 10 to the 5 times 5.0 times 10 to the negative 3. 10 to the 5 times 10 to the negative 3. We're multiplying. That means we're adding the exponents. So 5 plus negative 3 equals 10 to the 2, 10 to the 2. And then 7.2 times 5, what's 36? I think that's 36. So 7.2 times 5. Yep. So that's 36 times 10 to the 2. Now let's just say that this is dividing 7.2 times 10 to the 5 divided by 5.0 times 10 to the negative 3. We would be subtracting exponents. So multiplying your adding exponents, dividing your subtracting exponents. So this would be 5 minus negative 3, 10 to the negative 8. So we just want to make sure that we remember that when we're doing calculations by hand. I don't know what setting you'll end up in, but these are very important things to make sure you have grasp. I know for a lot of people, it's been a while since we've had a math class, and that's totally fine. That's why we're being here right now. Okay. Gonna skip a couple questions here, and we're gonna go to number 11. Okay. Number 11 I chose specifically because it takes some time for you to read and try to extract information and see how we're going to approach this problem, right? That applies to any problem in real life. You want to take your step back and see how we want to approach this person, approach this patient. You want to make sure, because you got to make sure you're catering to the right way before you attack in a sort of sense, right? Okay, if a pediatric vitamin contains 500 units of vitamin A per milliliter of solution, how many units of vitamin A would be administered to a child given 2 drops of the solution from a dropper calibrated to deliver 20 drops per milliliter of solution? Okay, so I think the best way to go about it, now, follow your own strategy that works best for you, but this is just a more general sense that I might be able to recommend, right? You want to write out what you have, first of all. So this vitamin A, it has 1,500 units per ml in that solution. Okay, and what they're asking for, the number of units per 2 drops. Uh-oh, 2 different units. Okay. And, okay, so the way of administrating those drops is through this dropper that is calibrated at 20 drops per ml. Cool. So we want to, the best way to go about this, what are they asking for first, right? Number of units per drop. We have the total, total amount, the total units per ml of a solution, and we have the amount of administration per ml as well. So the best way to go about it is to see what units are equal to each other in a sense, right? And then find a connection and then go by there to solve our answer. So for this one, for example, there's 1,500 units per ml and then 20 drops per ml. So we could say for every 20 drops, there is 1,500 units because ml, ml. If both of these equal a ml, then 20 drops also equals 1,500 units. I hope you guys get that, right? Because 1,500 units equals an ml and 20 drops equals an ml as well. Then 1,500 units should also equal 20 drops. That's how we start. Okay. So Okay. And now what they're asking for is the number of units for 2 drops. So if we're looking at this, we can see that, I hope that you guys have already know that with division, division can also be seen as a ratio, right? 1/2 for every one, there is 2. So for every 1500, there's 1 ml. So what we want to try to uh, find is the equivalent for 2 drops. Okay, let me just show it to you guys. So we have 1500 units. Let's start like this. This is our given. Right? Oh, wow. That's the same proportion unit to drop as what we're looking for. So we can find how many units we're for 2 drops because we're able to solve this proportion this way. Because we know, what do we know? We know that 1500 units per 20 drops. And then we also know that there's 2 drops given. What we don't know is the number of units for those 2 drops. But because of these ratios, we're able to find out how many units for 2 drops. So the way to go about it, solve for x. X equals, to isolate it by itself, you would have to multiply 2 over here, and then this leave at its, then x is all isolated, and then you can just solve for the rest. So that's 2 times 1500 divided by 20. Okay. Put that in our trusty calculator. 2 times 1500 divided by 20. PEMDAS, right? You could put these all together. It's not going to be a problem. 150. Is that the answer? Let's see. Yes, it is. 150 units of vitamin A. So what does this tell us? That there are 150 units in the 2 drops administered to a child. That's what, and patients are going to be asking this, or you might need to type it up in a label. So that's the reason why we're doing this. Okay. All right. I hope you guys are just, sure it might look simple, but it's just how to extract. What are we looking for? What do we have so far? Where's the connection? That's what's really important. Where's the connection? Because that connection is how you go from what do we have to what do we need. Wow. Someone quote that. That's beautiful. Okay, 17 is our next problem. Some of these questions, yes, they were from homework. If you guys have any questions you want me to, put out in a video, be more than happy to do that for you as well. Again, I just want to expand and just see how far we can go concept-wise, basing off the presentation that we have, right? The modules that we have. Okay, 17. Round each of the following to 3 significant figures. So A is, I don't know if you can see that, 200.39. Round. So we're allowed to do that. Round. They want 3 significant figures. What's the rule for significant figures for this class? because I don't know if you guys noticed, but it does vary from different grade levels and different settings as well. So for the pharmaceutical world, leading zeros before a whole number do not count, not significant. And that applies if it's also decimal. If there's zeros beforehand, according to this class, it is not significant. Zeros trailing or after a whole number, so like these zeros, for example, or if you add zeros here, those count. 1, 2, 1, 2, 3, 4, 5, 6, 7. That would be the number sig figs for, I don't know if you guys can see that. That number right there. Why? Because there's a whole number and then there's trailing zeros after that. Okay, so let's go ahead and solve this problem right here. We are given this number and they want us to round it to 3 significant figures. So we need to find out where the significance starts. Starts right here, the 2, whole number, first whole number. 1, 2, 3, okay. So that means we had to round from here, right here. 3 lower than 5, you round down, so it stays as 200. Okay. Now, another rule about significant figures. Yes, I did say it was trailing zeros, but for whole numbers, if you want those trailing zeros to be significant, you need that decimal point. Because just as a whole number by itself, 20 is one significant figure. Okay? I hope you guys aren't too confused about that. So the decimal point is also where things may get a little confusing, but to be fair, so 0020, that's still one significant figure, right? 0020 decimal points, that's 2 significant figures because leading zeros don't count, and then trailing zeros with the decimal points here conclude that this is significant. Okay, based off of that, let's try B. So 0.03629. So what do we say? Even with the decimal points, leading zeros are not significant. Okay, so these are not significant. Let's cut these out. So we start at the whole number, 3. 1, 2, 3. So we had to take this out. This is where we round. 9 is above 5, we can go round up. So there's different ways of writing this now. 3, 6, 3. That's 3 significant figures because the leading zeros don't count. Then it starts as 3 right here. Or what do we say about trying to make small numbers look neater? Put it in exponential form. 3.63 times, how many tends to go back to the original number? 1, 2, 10 to the 2, 10 to the negative 2, because we're dividing to go back. All right, so that's how we round with significant figures. And that's what I have for chapter 1. go ahead and move on to chapter 2. I do recommend you guys still going over the lectures first we before you come and check these videos out, because again, these are supplemental. These are just only help you visualize problems, but you still need to understand what we're visualizing, right? Cool. Man out.